lesson 4 in Algebra 2, video 4, and we're going to talk about polynomial factoring, and a lot of this stuff you learned in Algebra 1 before going to geometry and then now coming back to algebra. So let's look at a trinomial. We'll erase this. And what if I gave you, we'll just do a basic one now, x squared plus 3x minus 108. So remember from Algebra 1, we need to find, we have the terms here, we have the a term, the b term, and the c term, and we want to know what two factors can give us a product of 108, the c term, and yet at the same time give us the sum of the b term. So what do you think? Okay, well 12 times 9 is 108, right? So we know 12 times 9 is 108, so we're going to take our trinomial and make two binomials, like we've done in Algebra 1. We know we're going to have x's because we have an x squared. Now we have to be careful because we want to have a positive 3, right? So we need the 12 to be the positive number here, and 9 to be the negative, because 12 times negative 9 is negative 108, and 12 plus negative 9 will give us 3. So there it is. We just factored that, and we can get the roots if we want. We know the x is negative 12 and x is 9, right? So let's look at a more complicated one. Of course, you've done that in Algebra 1. What if we had 2x squared plus 9x plus 9? Now here we have to be careful because the a term is greater than 1. Now in the previous one, the a term was 1, right? Because there was a 1 next to the x. But when you see this, we have to do a different set of rules here. We first need to multiply the a and the c term. We'll get 18. And then we list the factors of 18. So let's list all the factors of 18. I'll list them here. Well, we have 1 and 18. We have 2 and 9. We have 3 and 6. And if you do it this way, you won't miss any numbers, that is, right? So, again, we multiplied the a and the c term. This is when a is greater than 1. Very important. When a is greater than 1, we did this. We multiplied 2 times 9, we got 18, and we listed the factors. Okay? And then we want to know what two factors here, if we add them together, we can get a 9. Well, here it is, 6 and 3. They give us 9, right? So then we know that it should be 6 and 3 as the factors. So let's write it now. We'll have 2x squared plus 3x plus 6x. That gives us 9x plus 9. Now, we're going to cut this in half. But before we do that, we may want to rearrange this. And I'm going to rearrange. I'm going to put the 6 here and the 3 there. And you'll see why in a minute. Then we have our two terms. We have a binomial here. We have a binomial here. We actually have 4 terms, right? But we're going to cut them in half. We want 2 on each side. Cut them in half. And then we want to do the GCF, the greatest common factor. And we're going to talk more about that in a minute. So the greatest common factor here is 2x. You can take out the 2x and then distribute it back. How can I get 2x squared plus 6x? All I need is one more x, and I need a 3. Now, I need to get x plus 3 over here, or else we did it wrong. So let's factor this out over here. What can I do over here? And that's not a minus, by the way. We had a plus there. Well, if I can take out a 3, I'll get x plus 3 also. There, we want that x plus 3 to be the same, and it is. That's why I put the 6 over here. You can rearrange it. If you put the 3 there, it wouldn't work out. And again, now we can bring this down a little more and erase this line here. And we can say now that our two binomials will be 2x plus 3, the 2x here and the 3 there, and it's plus 3 because there's no minus sign, and then x plus 3. There we go. Now, let's look at one where the first thing you should always do when you're looking at factoring trinomials is the greatest common factor. Right, we really want to look at, if you can see that, way up there, there we go, the greatest common factor, right, GCF, that you learned perhaps in 6th grade. So let's say we had something like this. What if I gave you 6x squared plus 14x plus 8? Now instead of doing where you're multiplying 8 and 6, let's make it a little easier. Let's do the GCF first. Let's break this down. So what can we break? What can we take out? Well, they all share a 2. A 2 goes into all of them, so I can take a 2 out, and then I'll just distribute back. I'll get 3x squared plus 7x plus 4. And now we can do some factoring with this trinomial here. So let's take the two numbers, 3 and 4, and we get 12. Remember that step? Now we can bring this down. And what are the factors of 12? Well, we have 1 and 12. We have 2 and 6. We have 3 and 4. Those are our factors. That was the next step. Now we want to know what two numbers here can give us 7. Well, 3 and 4 can. And then you have to arrange them in a certain way. Yeah, so let's say we had 3x squared plus 3x plus 4x plus 4. And we want to cut it in half. Now, before we cut this in half, before we cut the two terms, do you think these work? Do we have to change the 4 and the 3? No. See, they both have a 3 here. They both have a 4 here. So no. So let's make a line. Cut it in half. We can take out a 3 and an x, right? And then we'll get an x plus 1. And if we don't get an x plus 1 on this side, then something's wrong. And over here we can take out a 4 and then get x plus 1. Right, so our final answer there will be 3x plus 4 and then x plus 1. There's our two binomials. So we can bring it up here. I'll erase the GCF. The answer will be 3x plus 4, and then we have another one, x plus 1. That's how we factored. All right, let's say we had 12x squared minus 57x plus 36. Now before we look at the a term. We know the a term is greater than 1. But before we multiply 12 and 36 together here, let's see if we can do the GCF, the greatest common factor. What can we take out? We take out 3, right? 3 goes into all of them. So then we just distribute back. And we'll have a 4x squared here. We'll have a 19x there, minus 19x. And here we go, a 12. So a is still greater than 1, so let's now do 4 times 12. We'll do the a term times the c term, and we get 48. So what are the next steps as the paper falls? Well, the next step is to get the factors. And let me use a different marker. I'll use orange today for marker. There we go. Let's list all the factors of 48. We have 1 and 48. Well, we have 2 and 24. That works. 3 and 16. 4 and 12, and 6 and 8, right? Those are our factors. Sometimes you don't have to list all the factors. You can see as you're doing it which ones would work. Which ones do you think will work now? What will give us that b term if we add them together? Well, 16 and 3 will work, right? But you have to be careful of what signs you're going to use. So we'll have 4x squared, right? And then we'll say, well, minus 16x minus 3x. That works, right? Because negative 16 plus negative 3 is negative 19. Right? And we have that, and we have our plus 12. Okay. Let's go back to the other marker as it falls again today. Gravity's having a fun day today. All right, so now, do you think we have to rearrange the 16 and the 3x? Well, no. 4 goes into 16. Doesn't go into 3. So it's perfect as it is. We'll make a line here just to cut it up. And we'll say we'll take out the 4x. And when we bring this back, we'll get x minus 4. And again, we have to get x minus 4 on this side or it didn't work. So over here we can take out the 3x. It's negative 3x too, remember that. And then we'll, actually just the negative 3, don't take out the x. Just did a happy accident there. No. So if we took out the x, we wouldn't get x minus 4. So it's just negative 3, and then bring the x over here, and then minus 4. Because negative 3 times x is negative 3x, and negative 3 times negative 4 is a positive 12. So always double check your work. It's very easy to make a happy accident, as Bob Ross would say. So we have 4x minus 3. That's one term right there, one binomial. And the other binomial would be x minus 4. So we have our two binomials, and we factored it. All right. The next topic we're going to talk about is the difference between two squares. So if I had, let's say, x squared minus 100, we know these are two squares, right? The square root of x squared is x, and the square root of 100 is 10. So when you have the difference of two squares, again, this is from Algebra 1, it's always going to be a minus and a plus. So it'll be x plus 10, x minus 10. And if we did FOIL, we would get x squared minus 100. Both perfect square, right? The difference of two squares have to be perfect squares. So if we did, let's say I did x squared minus 6 squared. Well, we know 6 squared is 36, right? This will just become x squared minus 36. And these are the difference of two squares. Again, it'd be x plus 6, and it'll be x minus 6. Right? Let me bring that down so you see it. And then, yeah, let's do one more difference of two squares. And they're perfect squares, right? So if you did x squared minus 11, this is not going to work. 11, x squared minus 11 is not a perfect square. X squared is, but not 11. Again, one more that you should be familiar with. Well, what if we did this one? Here's one that's different. 4x squared minus 81. What about that? Well, 4 is a perfect square, x squared is a perfect square, and 81 is a perfect square. Again, we're looking at the difference. Make sure. So here we can take out a 2x, right? And we get a minus 9. And then we have a 2x plus 9. Right? And they're two binomials. And there should be two binomials, not a Venn diagram there. There we go. All right, that's the difference of two squares. And then the last thing we'll talk about today is perfect square trinomials. Another Algebra 1 review. So if you had, let's say, x squared plus 6x plus 9, you know this is a perfect square trinomial if you can take the b term, the 6x, divide it by 2, and square the answer. And if you square the answer and you get the third term, the c term, then it's perfect square. So let's look. If we take 6 divided by 2, we're going to get 3. And 3 squared equals the c term of 9. This is a perfect square trinomial. So tell me, is this a perfect square trinomial? X squared minus 18x plus 81. Well, let's see. We'll take the negative 18 over 2, and we're going to get negative 9. Negative 9 with parentheses squared, always put the parentheses there, is 81. So yes, this is a perfect square trinomial. All right, so we did perfect square trinomials. We did the difference between two squares. In the next video, we're going to talk about cubic expressions, and then we're going to do more complicated expressions, and then we'll talk about number proofs and identities. Okay, great job.